Have you ever wondered how a failed attempt at building an aircraft engine could evolve into one of the most iconic tank engines in history? Imagine an era where wars reshaped industries, and innovation was born from necessity. This is a story where aviation ambitions collided with wartime urgency, transforming a once-doomed project into an engineering marvel that left a permanent mark on history. The Ford GAA Phi-8 tank engine, a powerhouse of its time, wasn't born out of strategic planning, but rather as a solution to a misstep in the aviation world. But how did a machine originally designed for the skies end up conquering the battlefield? Stay with me as we explore the remarkable journey of the GAA engine, a story filled with intrigue, political tension, and mechanical brilliance. Before diving into the mechanics and performance of the GAA, we need to step back and understand the context in which this engine was born. The 1930s was a time of unprecedented global upheaval, with war clouds looming over Europe. The technological advancements during this period were fast-paced, driven by the need for powerful machines that could tip the balance in global conflicts. The Second World War wasn't just a battle of armies, but also a competition of industries, with nations racing to produce the best technology to outmaneuver their enemies. In this era, the development of engines, especially those powering aircraft and tanks, became a focal point for every major power. The Ford GAA Phi-8 wasn't simply an answer to a technical challenge. It was a result of a much larger story, one that began in the skies over Europe. Let's rewind to the late 1930s, where the world was teetering on the brink of the most destructive conflict in human history. European countries, especially Britain, were scrambling to defend their territories against the relentless German Luftwaffe. Central to their defense efforts was the legendary Rolls-Royce Merlin 512 engine, which powered the iconic Supermarine Spitfire and Hawker Hurricane aircraft. The Merlin became the engine that defined Britain's air superiority, but there was a major problem. The British couldn't produce enough of them. In the late 1930s, with the winds of war already blowing across Europe, the Rolls-Royce Merlin engine was seen as Britain's most vital weapon in its defense against the German war machine. It powered not only the Spitfire and the Hurricane, but also other aircraft critical to the Royal Air Force's ability to fend off waves of Luftwaffe bombers. But Britain was facing an industrial bottleneck. Their factories, stretched to the limit, were unable to meet the growing demand for Merlin engines. The RAF needed more planes in the air, but without engines, those planes would remain grounded. Britain's industrial capacity, weakened by years of economic depression, simply couldn't keep up with the war's demands. As Britain struggled to ramp up production, they turned to their ally across the Atlantic, the United States. While the U.S. had not yet entered the war, American industries were already gearing up to supply critical resources to the Allied forces. The Lend-Lease Act allowed the U.S. to send military aid to nations fighting the Axis powers, and it was through this program that Britain hoped to solve its Merlin crisis. But building an engine like the Merlin was no simple task. It required specialized materials, highly skilled labor, and precise manufacturing processes, none of which were in abundant supply in the U.S. at the time. Enter Maurice Olley, a British-born engineer who had made a name for himself at General Motors. Olley wasn't just any engineer. He was one of the leading automotive minds of his time. His work at GM had revolutionized the field of suspension design, and he had a deep understanding of the principles of engine performance and durability. Rolls-Royce approached Olley with a daunting task: help us build the Merlin in America. Olley agreed and set out to find American companies that could produce the parts and components necessary to assemble the engine. Olley's mission was critical. The Merlin wasn't just another engine, it was the heart of Britain's war effort. Its 1,600 horsepower V12 design allowed the Spitfires and Hurricanes to climb faster, fly higher, and turn tighter than their German counterparts. In the Battle of Britain, where every advantage mattered, the Merlin was a game changer. but Britain simply couldn't build enough of them on its own. Without more Merlins, the RAF would be overwhelmed, and the defense of Britain would falter. The stakes couldn't have been higher. Ollie's work took him across the U.S., where he negotiated with steel companies, forging specialists, and machine tool manufacturers to produce the critical components for the Merlin. He secured contracts with Republic Steel for crankshaft production, Wyman Gordon for forgings, and other American firms for the specialized alloys needed to meet Rolls-Royce's exacting standards. But the Merlin engine's production was still a struggle, one that required a more drastic solution. It was during this time that Ollie crossed paths with the Ford Motor Company, a name that would become synonymous with American industrial power during the war. Henry Ford, ever the opportunist, saw a chance to get his company into the lucrative aviation engine business. Ford's manufacturing expertise was unmatched, and the company was capable of producing engines at a scale few could match. But there was a problem. Henry Ford had little interest in building engines for Britain. His focus was on America, and he wasn't willing to devote resources to a foreign war, even if it meant helping an ally. This decision would set off a chain of events that would ultimately lead to the creation of one of the most iconic engines of World War II, but not in the way anyone had expected. Henry Ford was a man of contradictions. On the one hand, he was a brilliant industrialist whose assembly line techniques had revolutionized the automotive world. On the other, he was fiercely isolationist and often found himself on the wrong side of history when it came to global conflicts. In the years leading up to World War II, Ford had been reluctant to involve his company in military production, particularly if that production was destined for foreign powers. But as the U.S. inched closer to joining the war, Ford saw an opportunity to expand his business by getting involved in the production of aircraft engines. Ford believed that building aircraft engines could be a major business for his company. The U.S. military was in the process of ramping up its Air Force, and Ford wanted a piece of the action. He began work on a V-12 engine that was remarkably similar to the Rolls-Royce Merlin, though it had some distinct differences. The engine, designed to produce 1,800 horsepower, was a testament to Ford's engineering prowess. Early tests showed that the engine had great potential, and Ford was confident that it could become a staple of the U.S. military's air power. But there was a problem. The U.S. Army Air Force had already committed to the Allison V-1710 engine for most of its aircraft. The Allison V-12 was a proven design, and the military had already invested millions of dollars in parts, spares, and training for the engine. Introducing a new engine, no matter how powerful, would require retraining mechanics, retooling factories, and investing in an entirely new supply chain. The Army simply wasn't interested in Ford's new V-12, no matter how good it was. Ford's aviation dreams were dashed, but the story didn't end there. While the U.S. military didn't need a new aircraft engine, they were facing a serious problem with their tanks. The M4 Sherman, which had become the backbone of the U.S. armored forces, was in desperate need of a better engine. Up to this point, the Sherman had been powered by a variety of engines, none of which were ideal. Some used radial engines designed for aircraft, while others used twin diesels, or even the bizarre Chrysler multibank engine, which consisted of 5 inline-6 engines arranged in a pinwheel configuration. None of these engines provided the power, reliability, or ease of maintenance that the Army needed. The Sherman was a relatively lightweight tank by wartime standards, but it still required a powerful engine to move its 30-ton frame across the battlefield. And as the war dragged on, the need for a reliable, powerful engine became more urgent. This is where Ford saw an opportunity. Rather than scrap their V-12 engine, Ford's engineers proposed an idea: cut the engine down to 8 cylinders and adapt it for use in a tank. The resulting V8 would still provide plenty of power, and by simplifying the design, Ford could produce the engine quickly and efficiently. The U.S. military, desperate for a new tank engine, agreed to the plan, and Ford set to work transforming their aviation engine into a tank power plant. The transformation wasn't as simple as just removing 4 cylinders. Tank engines face different demands than aircraft engines. They need to be able to operate under extreme conditions, from scorching desert heat to freezing cold, and they must be able to run for long periods at high loads without breaking down. Ford's engineers made several modifications to the engine, including changing the block material, upgrading the cooling system, and strengthening the crankshaft. The result was the Ford GAA, an 18-liter V8 that produced 500 horsepower and over 1,000 foot-pounds of torque. This was an engine built for war, and it was about to prove itself on the battlefield. The Ford GAA engine wasn't just a stripped-down version of Ford's Aviation V12. It was a complete reimagining of what a tank engine could be. Building an engine for a tank, especially during wartime, was no easy feat. It had to be powerful enough to move a 30-ton Sherman tank across difficult terrain, yet simple and rugged enough to be repaired quickly in the field. The engine had to be reliable, able to run for hundreds of hours without failing, and easy to produce on a massive scale. Ford's engineers were up to the task, and the GAA became a masterpiece of wartime engineering. At its core, the GAA was a cast aluminum engine block with hemispherical combustion chambers, a feature that gave it excellent efficiency and power for its size. Aluminum was a key material choice as it kept the engine light without sacrificing strength, a critical factor when tanks needed to maximize mobility. The engine's dual overhead camshafts controlled 4 valves per cylinder, a design that was advanced for its time and allowed for better airflow, resulting in more power. This wasn't just an engine designed for raw horsepower, it was engineered for endurance and efficiency. The GAA's power output was impressive, to say the least. It produced 500 horsepower at 2,600 RPM and over 1,000 foot-pounds of torque across a broad range of engine speeds. This meant that the Sherman tank, powered by the GAA, could pull itself through thick mud, climb steep hills, and maneuver in urban environments with ease. The engine's design also allowed it to operate in a wide variety of conditions, from the cold forests of Europe to the scorching deserts of North Africa. Whether it was rolling across the beaches of Normandy or smashing through German defenses in the Battle of the Bulge, the GAA-powered Sherman was a formidable force on the battlefield. But the GAA wasn't just powerful. It was also designed to be easy to maintain and repair. Ford knew that tanks in the field would be pushed to their limits, and they needed an engine that could be quickly serviced by crews with limited tools and training. The GAA's simplicity was one of its greatest strengths. It used gear-driven camshafts and magnetos instead of complex chains or belts, reducing the number of parts that could fail. The engine's flat-plane crankshaft, forged connecting rods, and cast aluminum pistons were designed for durability, and its cooling system was optimized to keep the engine running smoothly even in the harshest conditions. One of the most impressive aspects of the GAA was its reliability. During testing, the engine was run at full throttle for 100 hours straight, an extraordinary feat for any engine, let alone one designed in the 1940s. The engine was also subjected to rigorous endurance tests, where it was run continuously for days on end to ensure it could withstand the demands of war. These tests were brutal, but the GAA passed with flying colors. It was a tank engine built to last, and it proved its worth time and time again on the battlefield. By the end of the war, Ford had produced over 28,000 GAA engines, each one a testament to the company's ability to mass-produce complex machinery under extreme pressure. The GAA became the preferred engine for the Sherman tank, and its success on the battlefield cemented its place in history. But the story of the GAA doesn't end with the war. It continued to play a role in the post-war world, both as a symbol of American ingenuity and as a beloved engine for enthusiasts. When the GAA-powered Sherman tanks first rolled onto the battlefield, they quickly became a symbol of American industrial might. The Sherman was already a capable tank, but with the GAA engine, it became a force to be reckoned with. The engine's power allowed the Sherman to outmaneuver many of its heavier, more cumbersome German counterparts, while its reliability ensured that it could keep going even when the fighting became intense. The GAA wasn't just an engine, it was the heart of the Sherman, and it played a critical role in some of the most important battles of World War II. The engine's versatility was one of its greatest strengths. The GAA could operate in a wide range of environments, from the frozen forests of Europe to the scorching deserts of North Africa. Whether it was pushing through the mud and snow of the Ardennes during the Battle of the Bulge or rolling across the beaches of Normandy on D-Day, the GAA-powered Sherman proved its worth time and time again. Its 500 horsepower and 1,000 foot-pounds of torque allowed it to climb hills, cross rivers, and break through enemy lines with ease. But the GAA's true strength lay in its durability. In the heat of battle, tanks often operated for hours or even days without a chance for maintenance. The GAA's simple, rugged design allowed it to keep going even when other engines would have failed. Its aluminum construction made it light enough to give the Sherman excellent mobility, while its advanced cooling system ensured that it didn't overheat in the intense conditions of combat. The engine's reliability was so well regarded that tank crews often preferred the GAA-powered Sherman over other tanks, knowing that it would get them through even the toughest battles. One of the GAA's most impressive moments came during the Battle of the Bulge in December 1944. The German army launched a massive surprise offensive in the Ardennes forest, hoping to break through the Allied lines and capture the vital port of Antwerp. The weather was brutal. Freezing temperatures, heavy snow, and fog made fighting conditions nearly impossible. But the GAA-powered Sherman tanks, with their rugged design and reliable engines, played a crucial role in holding the line. As German tanks bogged down in the snow and ice, the GAA-powered Shermans pushed forward, using their superior mobility and firepower to turn the tide of the battle. The Battle of the Bulge was a turning point in the war, and the GAA-powered Sherman tanks were at the heart of the Allied victory. But the GAA's legacy didn't end with the war. After the conflict, many of these engines found new life in civilian applications. Tractor pullers, hot rodders, and custom car builders began to take notice of the GAA, realizing that its power and durability made it perfect for high-performance applications. The engine's massive displacement and advanced design allowed it to produce incredible amounts of power, even by modern standards. Some enthusiasts have even managed to modify GAA engines to produce over 2,000 horsepower, making them a favorite in the world of extreme tractor pulling and high-performance racing. But beyond its performance, the GAA's legacy lies in what it represents. It's a reminder that sometimes failure is just the first step on the road to success. The GAA was born out of a failed attempt to build an aircraft engine, but it became one of the most successful tank engines of all time. Its design influenced generations of engineers, and its impact can still be felt today in the world of high-performance engineering. The Ford GAA engine wasn't just a temporary solution to a wartime problem. It was an enduring symbol of American ingenuity, adaptability, and industrial might. Today, the GAA remains one of the most iconic engines of the 20th century, not only because of its performance, but because of the story behind its creation. This engine, which began as a failed aircraft project, went on to power one of the most important tanks in World War II, helping the Allies secure victory against the Axis powers. Its story is one of innovation born out of necessity, and its impact can still be seen in modern engineering. Even decades after the war, the GAA continues to capture the imagination of enthusiasts and engineers alike. In the world of high-performance motorsports, the GAA has found new life as a go-to engine for extreme tractor pulling and custom car builds. Its massive displacement, dual overhead camshafts, and hemispherical combustion chambers make it a natural fit for those seeking maximum power and performance. With modern modifications, some GAA engines have been tuned to produce over 2,000 horsepower, making them some of the most powerful engines in the world. It's a testament to the GAA's design that even after all these years, it remains a favorite among those who seek to push the limits of what an engine can do. But beyond its continued use in motorsports, the GAA's true legacy lies in its role as a wartime engine. During World War II, the GAA powered thousands of Sherman tanks, helping to turn the tide of the war in favor of the Allies. Its reliability, power, and ease of maintenance made it a favorite among tank crews, and its performance on the battlefield was nothing short of legendary. The GAA-powered Sherman became a symbol of American strength and determination, and it played a crucial role in some of the most important battles of the war. The GAA also represents the spirit of American innovation. It was an engine born out of failure. Ford's attempt to enter the aviation engine market didn't go as planned, but instead of giving up, the company adapted. They reimagined the engine as a tank power plant, and in doing so, they created one of the most successful engines of the war. This ability to pivot, to take a failure and turn it into a success, is at the heart of what made the GAA so special. It's a story of resilience, of refusing to give up in the face of adversity, and of finding new ways to solve old problems. In many ways, the story of the GAA is a reflection of the broader story of World War II. It's a story of technological innovation, of industrial might, and of the determination to win against all odds. The GAA wasn't just an engine, it was a symbol of the ingenuity that helped the Allies win the war. It's a reminder that, even in the darkest times, innovation can light the way forward. As we look back on the legacy of the GAA, it's clear that this engine was more than just a piece of machinery. It was a triumph of engineering, a testament to the power of innovation, and a symbol of the determination that defined the Allied war effort. Today, the GAA remains an icon of American industrial history, and its story continues to inspire engineers, historians, and enthusiasts alike. So, the next time you hear the roar of a powerful engine, remember the Ford GAA, a marvel of engineering born from the skies but destined for the battlefield. It's a story of failure turned into success, and of an engine that helped shape the course of history. With that said, thanks for watching, and until next time.